All right, so hello everyone. My name is Sahadev Zala. Welcome to the Kubernetes SIG IBM Cloud meeting today on June 6th. Please keep in mind that this is a public meeting and it's being recorded, and we make this recording available on the YouTube. The agenda link is in the chat, and if you have any item, please feel free to add there. We seem to have a little light agenda today. We have a couple updates. I updated them, and we can talk more from other folks. It doesn't have to be added right away in the agenda. We can add them as we go. All right. So before we start with the agenda, even Danish and Nimesh, the talk we are going, right? So as Nimesh mentioned, Danish, the purpose is, to share the knowledge to help folks get on board on Kubernetes upstream. Any issues, anybody, IBM or non-IBM, or facing in the IBM cloud space for Kubernetes and related CNCF components, right? And those are the things we would like to discuss in this SIG, right? Or any basically a product specific features, right? In IBM Cloud, IKS, IBM Cloud Private, ICP, or other related IBM Cloud offerings. If there's any Kubernetes specific topics, right? The work which is going on, that would be great to share with the folks here, and bring any basically discussions, any issues with the upstream work that the folks here in the SIG, basically all the SIG members can take a look, help each other, right? Learn from each other, and make Kubernetes better, make CNCF commands better, make IBM Cloud better, and make the community better. Mm-hmm. So that's the goal, that's the purpose, and. Besides the meeting, we have a Slack channel where folks can discuss things. We have this Google group for IBM Cloud SIG, where people can exchange mails, right, for discussion. For today, I think let's just start with agenda, and then I think we all can contribute as we go forward with any discussion topics. So. As you see in the agenda, like I said, light agenda. We don't have any specific topic to present today. Like earlier, Nimesh mentioned, we usually try to bring some IBM Cloud related topics to share with the folks in the meeting. But it depends on the on the folks. I mean, we all are busy, so some sort of SMEs are not available all the time to talk about different topics, whatnot. So for today's meeting, I have first updates, cloud provider SIG related updates. So I put a bunch of links there. Not sure, this is more like an upstream related discussion. So right now we have different SIGs for a specific cloud provider, right? So IBM Cloud SIG, we have SIG for Azure, for AWS, for GCE, VMware. Those SIGs are still individual SIG, but the cloud provider SIG it's a newly created SIG. Alongside the SIGs I mentioned, if you look at the link, especially the third one, you can see that on the Kubernetes upstream repo, there are a bunch of cloud provider specific codes, drivers for the Kubernetes, AWS, Azure, and few more there. IBM Cloud is, we don't have anything there right now. These are some of the, I think, legacy content, which is right now in a sort of in freeze state, as they're working to find a better way for cloud provider to provide their own code here. So, with this new cloud provider SIG, again, then I have provided a link, the very first link. That special interest group, it's gonna cover or own all this code which is mentioned here as sort of like a sub projects. And down the road, I think the goal is to have all cloud provider SIGs, right, including us, to be part of like a sub-SIG of the cloud provider high-level SIG, and everyone basically, work under this bigger umbrella. So that was an update. That this all thing just, there was some discussion going on back and forth for last couple months. Right before, a month before, I think, last KubeCon in Copenhagen. But this work is finally being, like a decision has been made, finally being merged. And that's where this new SIG is created. So that was a quick update. If you have questions, let me know.
So Dev, are you going to open up a PR to get IBM Cloud added to that list?
Yes. Yep. No, that's a good question. Like, yes. I think I'm not gonna do the right way though. Right now, I think all SIGs are still the SIG itself. I mean, I think all the cloud provider code the Kubernetes repo has, they are all already under this umbrella. And part of some file changes, I see some of the other SIGs as well. So yes, I'll be working on that. That sounds
great. Thank you.
Yep, absolutely. Thank you. Hey, thanks for the meeting notes, Doug.
Yep, anytime.
Sure, thanks. All right.
Do we have a readout as to the direction of cloud providers within Kubernetes? I know there's been some talk of kicking them all out. There's not been a lot of action though in that area, and I've seen a mixed bag of options that have started to come in as far as an external cloud provider. So do you guys, or does anybody know, where are they trying to get to?
Well, if I understood your question correctly, Richard, I mean, I think they trying to sort of have some consolidation over all the work going on under different SIGs, right? Under more like in one bigger SIG, special interest group, and have the existing cloud provider SIGs, and down the road, I mean the discussion was that hey, down the road we may have several other cloud providers interested in having their own work being done in the upstream side, have their own special interest group, so have them sort of consolidate into one place. Not sure, Richard, if that's correct answer or if you're looking for something else.
It's more of the technical question. Like right. The code base for Google and others are in Kubernetes. Ours are not, because they don't want to add new ones, is my understanding.
That's true, exactly. So in the agenda, the third link, right? I think that's where I have uploaded the upstream link for the code. That is true. If you can look, if you like, on that particular link, if you go back to cloud provider and look at the README, I don't know if you already looked at it, Richard and everyone, but that's where it shows some of the ongoing, like it says, guidance and some of the proposal and some of the future actions there. And the reason why everything is under sort of a code freeze there, well, those guys who already have the code, they can make changes, but for any new SIGs or new cloud provider, I mean. But I think down the road, I think they've been, and again, I'm not into that discussion, but the discussion is going on to provide a better way so that new cloud provider can come on board, right? So that's what I think. If we are interested, IBM Cloud, I think that will be the opportunity then, once that new path is being formalized.
Yeah, that makes sense. So yeah, definitely. So we want to be a part of that discussion going forward. Okay.
Yep, absolutely. Yeah, exactly. It will be good to see also that as well. Yep. Absolutely. All right, thank you. Then the second updates, it's more like an I know Richard and Jake, I think, and other folks who've been joining the call regularly. I think a couple 3 weeks back, I think May 9th meeting. So couple 2 meetings back, right? We are bi-weekly meetings, so month back. One thing we mentioned as part of the KubeCon updates was some of the work they're doing in the SIG scalability related to some of the performance comparison, right, between different cloud provider. And I think the guy Shyam from Google, he seemed very deep into this, and he's created this nice document. That's the link I actually shared that a month back SIG meeting. But lately I was just taking a look at that link, just to educate myself and see what's going on. If by any chance we can sort of take a look and see if we can contribute there. But then I found that that link was already sort of expired date link. So I provided the new link. It was removed from the SIG scalability repo to this new benchmark repo for test. So it's there. I just wanted to let everyone know. I know Richard, you and I think Jake Kishner did show some interest. I mean, I think, and I know it was even mentioned that from Jake's side, some discussion was from IKS side. I think there was some participation in the SIG scalability. So I just wanted to give these updates, and I know Richard, if you if you want to now or even later, but have this as more like a to-do kind of item and reach out to IKS team. I think especially Jake, and see what's going on from our side to the SIG scalability contribution or any discussions related to this sort of some performance measurement.
Yeah, I can definitely reach out to them and see if we can get them in a future meeting.
Okay, absolutely, great, thanks. So that, I think I see those are the two topics down there, two updates mainly. What else? I mean, I think it's an open discussion, but Dennis, if and we were just talking a little bit early in the meeting, right? If you want to share something, some of the work. I mean, are you guys like even doing anything on the Kubernetes upstream side, or you are more like using Kubernetes and in the CI/CD work, kind of little bit more overview to everyone? That'll be great. I know
sure.
It's, okay.
Sure. I guess I'll just say thanks for putting me on the spot there. That's awesome.
I know. I was about to say that. Hey, I'm putting you on the spot. Yeah.
That's great. That's great.
No prep.
Okay. Yeah. No prep is perfect. I always like those presentations. So a little background on me. I'm new to IBM. I've been here for like probably a year, maybe a year and a quarter, something like that. But in coming, probably the first 3 months, the first thing we did was said we're going to use this thing called Kubernetes. And my first words out of my mouth was, "What's Kubernetes?" And so we've been doing it pretty strongly here for probably almost a year now. And we're building this thing called ZNCP, which is basically the network control piece of that's underneath, call it, I guess you want to call it IBM Cloud. I mean, it basically works with software and things like that. But one of our challenges, and so in the end, as far as Kubernetes, we're using Kubernetes in terms of making microservices and all that type of stuff to drive the networking components and actually talk to networking devices that set up the networking underlays for the cloud services for our customers, if that made any sense, hopefully. But one of the challenges we have, Kubernetes, is just the learning curve. First of all, the old timers are like, why don't you just make a couple of servers, put some programs on it, run it, you're good to go, right? And then we have to educate them about some of the scalability aspects of Kubernetes, how it keeps things HA and all this other stuff. But one of the biggest challenges we have is that, for example, with our Armada team and all that stuff, is the things we're doing are actually going to be things that support that stuff. And we're always worried about, we would love to get out of the Kubernetes business and have, the Armada team or whoever, spin up our Kubernetes clusters for us. That way we can build things on top of it. But we have this challenge where we have this circular dependency. Like, we can't use them to spin up things that we're going to use to drive them underneath, because we're providing the networking component for that. And if that fails, then we won't be able to do any debugging. So our solution was to try to gain the expertise on our own and actually spin up our own Kubernetes clusters by creating VMs or bare metals and spinning them up that way. And the tool we're using is KubeSpray. So we've been using that for about a year now. And we have various sets of automation that we've evolved over time so that we can very quickly spin up a cluster. Quickly in my world means roughly about 20, 30 minutes. You can spin up a cluster and actually be able to do things with it.
Yeah, Dennis, so sorry to interrupt. That's great.
Yep.
Did you have anything on the Kubernetes upstream side? I mean, you guys, I think you don't contribute, right? Straight there?
Yeah, I don't. I would like to eventually, just for my own knowledge and if there are bugs and things, because one of the challenges in terms of doing that, of going with CI/CD and actually making the infrastructure is Kubernetes upgrades. I mean, it's like, think of it as Windows upgrades. I mean, you don't have to do Windows upgrades, but if you do, you get the benefit of security patches, bug fixes, and so on. And in fact, there may be certain regulations or whatever that may come into play for compliance. We have to keep things upgraded and patched and stuff like that. And in fact, one of my thoughts here is that the challenge is how to upgrade Kubernetes in such a way that it's not disruptive. I mean, there's playbooks inside KubeSpray that can upgrade, but there's always the question of, is your service going to be down? And I know Kubernetes has this concept of moving the microservices from one to another and making sure that they spin up again. But during that time, that those pods are gone, and then the service is down for some amount of time. So the contributions that we hope to make are just in that space, and maybe possibly in some of the testing of that, to know that there is, or to be able to have some visibility into how long the services are down. But we haven't made any contributions yet.
Gotcha. No, that's great. Thanks, Dennis. And if you haven't made anything, any contribution yet, right? Not being like a regular upstream developer, I mean, the SIG folks can help you, or your team if you need some help getting started on board, or with the testing, right? Some other stuff like setting up the environment or whatnot. Reach out to me or anyone. Most of the folks.
Okay. I just saw from Morgan here, and nice to meet you, Morgan. It says something that Armada already supports. Like I guess what I'm calling it is a graceful Kubernetes upgrade. What is the IKS?
It's a IBM Cloud Kubernetes service. That's our public Kubernetes service.
Okay.
Yeah, so I can talk a little bit about that upgrade, and I understand where you're coming from, because I think a lot of our users on IKS have similar concerns where they view an upgrade as that big thing that you may have done and hit that button on Windows or your operating system or your phone, whatever, and you fear that button because you don't know what's going to happen, right?
Exactly. Yep.
So, I mean, we've done in IKS, we've upgraded, and if you talk about major, minor, or just even patch level upgrades, thousands of clusters and worker nodes and so on. So it's not as, from that aspect, it's not as intimidating as you might think it'd be. Kubernetes actually does a fairly good job of doing upgrades and updates of your master and your worker nodes. And the tools that we have in place help you do that in kind of a seamless fashion. I think the biggest problem that folks have seen, though, is that their applications are not ready for upgrade. Meaning, for example, they may only run one pod, right? Or they may run multiple pods, but sometimes they're on the same node, or they upgraded everything at the same time, or their application just couldn't handle that few minutes of downtime for that pod. So I think that's where the fear really comes in, and Kube has tools to help you do it right. It's just a matter of learning those tools and using those. And
okay.
App to handle that, right?
Yeah, I think what you said mainly about, it's the application piece that we're wondering is just not ready for. I think that kind of hits the nail on the head, because as you look at all the demos, I mean, I think even in KubeSpray, there's a playbook that says, okay, drain all the pods from this node here, cord on this node, okay, upgrade this node, and then, move on to the next one. And it does that one at a time so that you are never out of workers. There's always a pod running somewhere. but it's that logic where you where a pod is actually having some in-flight transaction. You have some timeout. You say, okay, take them off the load balancer, finish the transaction. Meanwhile, let somebody spin up somewhere else and start, telling the load balancer to put that guy on the list so that he actually starts taking things. And it's that type of logic that we're trying to figure out how to do. And when you say that Kubernetes has tools for these type of things, are there is it in the form of operators, or or maybe it's just a matter of I mean, what are some suggestions in that area that you might have?
So the tools that I'm referring to would be some of the things you could put on a deployment. For example, you could set up a readiness probe, a liveness probe. You could configure replicas to be in the rollout that you want, how you want a rollout to happen on deployment, so that when things go down, how is it structured? So some of that aspect is what I'm referring to. But the transactional based stuff, certainly there's additional complexities there.
Yeah, it sounds like we have to just make kind of our own tooling that's kind of application specific to take care of those things.
Right. I don't think Kubernetes is going to give you application transactions. Yeah. I don't know of that. Yeah.
Okay. But I think there is a concept of let's say number of replicas equals like 3, for example, and then I know that and 3 of my replicas are running on 3 different worker nodes, and if I'm going to upgrade one, what I would do is take one out of the load balancer and then let him continue with in-flight transactions, and then let him finish. Once he finishes, kill the pod, then start upgrading and do some kind of algorithm like that.
Well, Kube does a lot of that. Kubernetes will do a lot of that for you.
Okay.
That's what a readiness probe will allow you to. That will handle endpoints leaving and being added to service. Okay. So, liveness probes help there as well.
Yeah, but Richard, just a quick question for you. In order to do some sort of those upgrades, I understand you can use the liveness probe or health check, all the other stuff, so that the load balancer will avoid pods that aren't ready. But am I correct in assuming that the application within the pod itself has to have built-in knowledge to start returning that he's not ready because he's in the process of being upgraded, or he wants to start the process of being upgraded? I mean, Kubernetes doesn't help you out there, right?
I'm trying to think here. So you're saying like the application knowing that an upgrade is happening?
Well, in order to do an upgrade, right, you want to make sure that no new incoming messages are being sent to a particular pod, so you can go ahead and upgrade it, right?
Yeah.
Well, Kubernetes, as far as I know, does not have any logic in there that will stop routing things to a particular pod, and then when all those connections are dead, it will do the upgrade. Or does it have that logic?
The first part, not the second part.
But how does it determine the first part? I assume by liveness probe, right?
You can say stop sending new connections to a thing.
Right. That's my point, right? It's almost like a manual process, right? You have to have some sort of orchestration logic in the application or in your own external tooling that tells Kubernetes, stop sending stuff to this thing. Then you have to detect when things are stopped being sent there and you're no longer processing anything. Then you can go ahead and do an upgrade. Right?
There's a hook you can run. You should write you have to write your application so you can turn them off.
Yeah, exactly. So there's hooks on post, pre-stop hooks and readiness probes. The readiness probes help you control the endpoints coming and going so that the app is actually ready or not ready to receive connections from the service. And then there's a pre-stop hook that allows you to kind of flush things out before it fully terminates the application.
Okay.
The problem is they're not perfect, and there are room for improvement. And my understanding is certainly there's some area there that can be enhanced. I agree.
Yeah, because that's the part that I always thought was kind of interesting, is that when you do your upgrade of your deployment or your replica set or whatever, it seems like Kubernetes should handle some of the stuff for you automatically, right? Say, okay, it wants to upgrade this particular pod, so it removes it from the load balancer, waits until it detects there's no incoming messages being processed anymore, then it takes it offline, whatever mechanism it wants to, upgrades that one pod, brings it back online through the load balancer, and then moves on to the next one.
Yep.
Right. And I saw this interesting blog about this. Some folks doing the basically setting up, instead of using necessarily the rolling update path, they created 2 services, right? And then their backends for that. And they basically drained out one service as they brought up another service. But that's more manual tooling that would have to be built on top of that.
Exactly, right.
Yes, that was kind of my plan, was to do that kind of blue-green type thing where you explicitly say, this guy's going away, no more new transactions, and then you just kind of do everything manually. So speaking of the things about the readiness probes and the things that, you said there are timeouts to wait. I mean, first of all, there was one to say, stop sending new transactions to this pod because it's going to be upgraded or whatever. Is there any maybe some repo somebody can point me to for an example of how they do something like that? And it doesn't have to be up for my particular application of this technique is really for being able to get graceful Kubernetes upgrades. But it could just be a matter of, drain a pod, stop, let it continue running current transactions, and then stop doing things to it, and then go ahead and kill it. That way it can come back later on another node or something like that. Is there any example someone can point me to?
No. I need to see the app to understand what the problem is. I don't understand it anymore.
Okay, let me just take. Okay, there's 2 pods, and I have let's call it a fictitious 3-node Kubernetes cluster. Let's call it 3 pods. 3 pods, 3 nodes. I want to upgrade, and they're taking transactions constantly. They're on a load balancer, let's say, taking transactions constantly, and then I want to upgrade the first node. And so the first thing I want to do is, one thing you said, Morgan, was something about you can tell Kubernetes to stop sending transactions to a particular pod. So I guess the first question is, how do you stop that? And then you have something where you can wait for that guy to drain. And once he drains, you can basically destroy that thing, so that then I can go ahead and upgrade that particular Kubernetes node. Does that kind of make sense?
Yeah, I mean, again, the first part's the easy part. Taking it out is you take it out of the label selector. You take it out.
Okay, I'm familiar with that. That's what I thought. Yeah.
Yeah, I mean, then wait until it's done. You have to either have some kind of pre-stop hook, or you have to make sure it can terminate within a certain amount of time, or you have to be able to just turn it off. And if there's something still going, and shit happens, stuff turns off. I would think you have to be able to successfully solve that case anyway. So now that it's dead, start the next one.
Okay, so it's still kind of a manual. I mean, that what you just mentioned is kind of the algorithm I was going to follow. It is kind of a manual thing. You basically pull it out of the load balancer, wait around, or give it some kind of timeout, then basically kill the thing, and then go ahead and cordon and drain the actual Kubernetes worker node, and then don't let pods go to it. Do its upgrade, and then put it back online, and then repeat the same thing with the others.
I feel like that already exists somewhere.
Yeah. I think that what you should read about readiness probes.
Okay. Let me do that.
Yeah. So I was experimenting with the exact same thing you're talking about, and I was seeing what happens if I kept hitting a deployment, 3 replica deployment, and while I was a rolling update going on, okay? And it was hitting a pod because it was terminating, and the endpoint was still there in Kube, and you get that drop connection. So you get several of those. Well, I think the readiness probe helped a lot of the cases, and then there was the pre-stop hook that helped the remaining cases to close the loop close enough that I was satisfied. So anyway, I look at those, and I know they're not fully complete as far as they're not going to solve everything.
Mm-hmm.
And they do require your app to actually close out relatively quickly. It won't wait forever, right?
Yeah. Okay. Yeah, I thought there was a concept of a timeout, like, or a grace period. I think they called it.
Right, there is. Mm-hmm.
Okay.
I
So
mean, you can configure that. You have to configure how long you're going to actually wait for a termination.
yeah. Okay. So
That's
I need
on a node, like if you're going to drain a node or coordinate off, whatever, you have that period of.
Yeah. Okay. Let me poke at that a little more and the readiness probe thing as well. Because I think right now we're just doing straight, rolling upgrades and stuff like that. And it's just, popping the nose and then bringing the new ones up, irrespective of in-flight transactions. I think what we do is our algorithm is, okay, everybody stop what you're doing. And then we let everything quiesce. We make the upgrade, and then we allow people to get back in.
Yeah, Kubernetes doesn't have that logic that Cloud Foundry does, which handles a lot of this stuff for you under the covers, unfortunately. That blue-green deployment stuff you talked about. Cloud Foundry has that built in.
Yeah, I'll study that one up. I'll probably have to come up with some kind of proof of concept type thing. I kind of just pseudo coded it out, but it felt very manual. But it sounds like that's, I guess, because it's very application centric type thing. We have to do manual stuff.
Yeah, Kubernetes isn't as opinionated, therefore you have to do more stuff yourself.
Mm-hmm. Yeah, I think, and I just thought, I know that KubeSpray has a playbook to go ahead and it goes through an algorithm of one at a time, cordoning nodes, draining, cordoning, and then actually upgrading them and doing them one at a time. And I wish I could sort of like integrate my logic to take care of the application type stuff into that. That would be an interesting experiment. But thanks for that. So how does everyone feel? I mean, speaking of, there's upgrades, there's Kubernetes pieces upgrades, but there's also, like, let's say you run the thing, you have Ubuntu 16.04, right? You take it out of the box, install it, run Kubernetes, everything is hunky-dory. But then for compliance, there's a concept of Nessus scans, for example, of one, right? And Nessus is probably, you run Nessus probably every week, you're going to find new vulnerabilities every week, which require what they call remediation or mitigation processes, which a lot of it is a yum update or an apd get update or whatever. How do you guys feel about doing that like regularly on a Kubernetes cluster? Has anybody been down that road before? It's just like doing a Windows upgrade. I'm always scared if I have to keep upgrading every week on an operational production type setup.
On the host?
Yeah, on the host itself. It's not Kubernetes specific.
I mean, you should be comfortable with spinning up your either spinning up new hosts and replacing them or whatever your normal upgrade path is. I mean, that's a normal thing to have to do.
Right. And what we do in IKS is we set up an image that we give, that's used by customers to create a node for their cluster, right? Uh-huh. And we continually update this image and the kube version associated. So if they're at like 197 today, there'll be an associated 197 for their worker, right? And then we'll keep that patch not only on the kube side, but on the host side. And if there's an update available, it's basically we're going to wipe things out and reload completely when you request it. So that's kind of how we've taken it forward, is like we have a golden image and we just keep moving forward with it.
Okay, so the golden image basically evolved.
Add a new worker, it's the new image. It's the new stuff. And you reload, you go to the new. It's always forward.
Okay. So it sounds like your people's Kubernetes clusters are never really static. They're always either upgrading Kubernetes itself or doing patches. And the way it sounds like we're doing it is we're just kind of on this train where we have 5 nodes and there's always this moving window where node number 5 gets removed and patched with a new Kubernetes, new patches, and you just keep cycling the nodes out so that they're constantly being upgraded. Interesting. Which makes it then just needing to be real good at being able to gracefully move applications over to new worker nodes or off of old worker nodes and just constantly replacing them.
Right, and I think if you look at HA in the cloud, right, you have to expect failure. So I think if you design for failure, that's a big key. Nodes will die, pods will move. Kube's very dynamic in that nature.
Yes. Okay. Okay. Yeah, I like the idea of things constantly moving like that. I always call it the rental car principle. You just want to get a rental car, you do your thing, get the next rental car, and if it dies, who cares? Just get another one and keep moving your stuff over.
So Dennis, I just slacked you some links to some Slack channels internally that you can use to get some help with some of these specific questions.
Okay, that's great. This is Doug.
Yeah.
Thank you, Doug. Oh yeah, okay. I'm definitely on Kubernetes Armada users. Okay, I haven't really looked at that one just yet.
It just yeah. Okay.
Okay, thank you very much, guys.
Yep.
Yeah, like I said, this is totally an evolutionary thing for us. I mean, we try to bust it pretty hard here. I'm more. I consider myself more of a big explorer. If there's a new thing, a new way to break something, I like to see it break, and mostly so that we can find new ways to fix things, because that's what I want to do, is be able to fix things, because when something breaks in production, that's I hope that's not the first time I've ever seen it.
Yeah, absolutely. And as we try to fix something, if it's on upstream side, well, one more time that we try to contribute back to the community.
Mm-hmm.
So
yep.
That's something to keep in mind. Yeah. Awesome. This is great. Very good discussion, everyone. So we're reaching to the sort of many time limit. We still have like 10 minutes, and we can go more if you want. But any other topic anyone wants to talk?
Oh, no, I was just going to mention to Dennis, this is Mike Brown. I work on the CRI implementations of, for Kubernetes. So if you've got any problems with Containerd or Cryo, send me a message or whatever. I'll give you some.
What is it that you work on, Mike?
I'm a maintainer on Containerd and Cryo. Mostly I work on Containerd.
Okay, that sounds great, man. Thank you.
Sure. Yeah, especially if you're going to break it.
Yeah, okay.
You just open up an issue, but if you'll poke me, I'll jump on it right away.
Okay, sounds good. Containerd. So I'm not familiar with Containerd. Is that always in Kubernetes?
No, it's available as an alternative runtime. Kubernetes currently ships with the CRI for Docker implementation.
Yes, that's what we're using. Okay.
Yeah, you're using Docker. There are a few projects on Armada and a couple others at IBM that are running on Containerd, practicing it out. I suspect we'll also be on Cryo, since we're doing this OpenShift work, and they're using Cryo. And these are all using the CRI interface that Kubernetes supports. The only question is, how long will there be support for Cry Docker? And it looks like the Docker team is willing to pony up some headcount for that. We'll see what happens. Maybe there'll be some announcements at DockerCon. We'll find out.
So how is the sentiment out in the community for migrating out to Containerd versus Docker? I mean, we've been pretty happy with Docker so far.
Alibaba's on it. They seem to be happy with it. I haven't seen a whole lot of feedback yet. It's been mostly developers poking around.
Yeah, on the IKS side, we definitely want to explore Containerd and are doing that, because we believe that it'll give us the performance we need and the scalability. Yeah, it's a little faster, because it doesn't have the rest of the Docker baggage to pull along with it. The Docker release will eventually be using the exact same Containerd underneath the covers anyway. So unless you needed to go after Docker SOC for something specific, that's outside of the CRI API, then you'd be fine just running Containerd.
Okay. Yeah, one of the reasons why we've gone with Docker and kind of stuck with it. It seems that the training path is pretty nice, because you can basically take people who are Docker people, and you say, oh, yes, you do Docker, cool. That it's still containers, those same containers. Is there a similar learning path, a pattern like that? Like everyone knows, Docker IO. I made a Docker thing. I loaded up to Docker IO. I can download your thing and try it, and that's how
it's similar. It's more of a Containerd as a subset. Mm-hmm. If you're using Docker as a tool for as a developer to build images and things like that, you'll probably want to stay there, because Containerd doesn't replace Docker. It's more of a Containerd as a subcomponent of Docker.
I see. Okay.
Okay, so if you're just using Kubernetes, you don't really need Docker there, right?
Mm-hmm.
There's two APIs or two client tools that are available. One's called CTR for creating Docker containers outside of Kubernetes, mucking around with Containerd. If you don't really care about Kubernetes, if you're using pods and things, you'll want to use CRI CTL, which is a supported command line utility for any CRI implementation, including Docker. And it allows you to use commands that you're familiar with to list pods and spec pods, but containers, things like that. Both APIs look like the Docker API a little bit. So you can do a ps.all, for example. Right?
Okay.
Pull images, that kind of stuff. Yeah, it's not far out. It's not exactly the same. On the cryo side, the Red Hat guys do have their own version of Docker, so you could use that. I think they call it Podman or whatever. I can't remember.
Okay.
Or K or something like that. They own settings for replacing Docker in OpenShift. Again, it depends where your customers are, right? If they're using Red Hat, I guess you're on Z, so it don't matter for you.
All right.
Wow, that's cool. That's great.
Just poke me if you need links or something to the docs.
Yeah, that sounds good. Thank you, Mike.
Sure.
That's nice. Anything else, anyone? I guess we're almost there at the meeting time, but I'll take if there's anything else. Doug, Brad, anyone?
Nope.
Thanks for your help, everyone.
No,
No problem. Yeah. That was a good discussion. So that was great. Thank you. Thanks, everyone. All right. Well, if there's no more discussions, I'm gonna stop the recording now. Have a great rest of the day and next couple of weeks. We'll see you in a couple of weeks. All right. Bye, everyone.
Bye.
Thank you.
Thank you.
Yeah.